Today's video is going to cover solving quadratics by factoring. We've done a lot of factoring of expressions, and now we're going to use that to solve equations. So our goal today will be to factor a quadratic equation in standard form to solve for the variable. A couple things you need to know before you begin this lesson. The first one being the zero product property. This is a conceptual idea that we're going to use as we solve quadratics. So the zero product property, and this is the mathematical definition, if a times b, where a is a factor and b is a factor that are both being multiplied to each other, equals 0, then either a, the factor a, needs to be 0, and that looks like an O, or the factor b needs to be equal to 0. So one of these two factors needs to be 0 for the entire thing to equal 0, because anything times 0 is 0, right? So that's going to help us as we solve. So for example, if we've got 0 and we've got x times y equals 0, then either x has to equal 0 or y has to equal 0, right? One of these two has to equal 0 for the entire thing to equal 0. Quadratic equations are to the second power. So we've seen that these quadratics are to the second power. So here's an example of a quadratic. And when we solve these, therefore they have two solutions. So because it's to the second power, there's going to be two values for x when we solve for x. Like if you think about the equations that you're used to solving, like x plus 5 equals 0, that exponent on that x is a 1. And so then when we solved for x, what we got is one solution because the exponent was a 1. This exponent, or the highest exponent in this, is a 2. Therefore, we're going to have two solutions. So the exponent kind of tells us how many solutions we're going to have. And in fact, the reason why we have two solutions is because a quadratic equation looks like this. It's like a U shape. And almost every quadratic crosses the x at two different places. There's two x-intercepts. Very different than these linear equations that we're used to seeing, where the line would only cross at one place on the x. These quadratics are going to cross at two, so we have two solutions. Okay, so let's go ahead and get into a couple examples today. Example number 1. Solve for x, enter values in numeric order. So since we're going to have two values, we're going to make sure that we put them in numeric order into Schoology. So the first step is to eliminate all terms on one side. We need these to equal 0 because we're going to use that zero product property to be able to solve. So if your equation does not equal 0, your first step would be to eliminate all terms on one side by using inverse operations. This one already equals 0, so we can go ahead and move into the second step. Second step is to create two factors. So you want to either look for a common factor, something you can factor out of both of the terms, or if you've got three terms, then you're probably going to have to factor the quadratic expression kind of using the box method, where we're trying to find two numbers that multiply to c but add up to b. So when you look at this example right here, we've got x squared plus 12x equals 0. So there's no c term really, and if we wanted to put plus 0 for the c term, we could. But this is one of the examples that we can just look for a common factor. We know that both of these terms have a x that we can factor out. So if we factor out the x from both of these terms, just one x, what we're left with inside parentheses would be x plus 12. Multiply that back in, we would get x squared plus 12x equals 0. So we've now created our two factors. The first one obviously is this factor right here. That's our first factor. And our second factor is this right here. So these are the two things that are being multiplied. X times x plus 12. And now our third step is going to be to solve each factor. So we're going to take the first factor and we're going to set it equal to 0. We're going to try to figure out what number for x would make it a 0, because if x is 0, 0 times this second factor would equal 0. And then we're going to do the same thing for the second factor. So for the first factor, x equals 0. I set it equal to 0. I set it equal to this 0. So this is already solved for us. If this first factor is 0, then the entire thing is going to be 0. If we do the same exact thing for the second factor, we're trying to figure out what number for this x would make this factor equal 0. We just take that factor and we set it equal to 0. So x plus 12 equals 0. Now we're going to solve. So x equals a negative 12. And you kind of could probably tell without even having to solve this that the number for this factor that would create a 0 in this parenthesis would be the opposite of a positive 12, which is a negative 12, and that's going to be the case for a lot of these examples. So our solutions here are x equals negative 12 or x equals 0, because both of these numbers would create a 0 in one of our two factors. And negative 12 is smaller than 0, so our order is this. Okay, example number 2. So here, our first step is to eliminate all terms on one side. It doesn't really matter what side you try to create the 0 on, but I'm going to leave the x squared here. It's positive. I like dealing with a positive in front of my x squared term, so I've got to eliminate this negative 5x. We're just using inverse operations here, so we're going to add the opposite, and we're going to make sure we add it to this side. These are not like terms, so we can rewrite this expression as x squared plus 5x equals, now we've got our 0 here. So that was our first step. Now our second step is to either look for a common factor or factor using the box method. I guess we'll refer to it as. So again, we can see that both of these two terms have an x that we can factor out. So let's go ahead and factor out the x, and we're left with x plus 5. So now we've got our two factors, the first one being this x right here, the second one being this x plus 5. So let's take the first factor and set it equal to 0 and see what number makes the first factor equal 0. Because it's just an x, we know that 0 makes this factor equal 0, so our first solution is 0. And then we'll take the second factor, x plus 5, and we're trying to find out what number for x here would make this second factor 0. So we're just solving for x, and we know that we're going to get the opposite number, because when you add opposite numbers, they add up to 0. So we've got x equals negative 5. So these are the two values that would create a 0 in one of our factors. And we know that 0 times whatever it's being multiplied to is going to equal 0. That's why the zero product property is important in these examples. We're going to put it in numeric order, negative 5, comma, 0, done. Example number 3. Solve for x. Okay, so here we have x squared plus 2x equals 8. So our first step is going to be to eliminate the terms on one side. It's probably best to eliminate the 8 here, since there's only one term on this side and there's 2 here. It's always easier to eliminate less things. So we're going to subtract since it's a positive, and we're going to minus 8 on this side of the equation. There's no like terms here, so we can rewrite the expression as x squared plus 2x minus 8 equals 0. So now we've got our 0. And now in this example, unlike the previous two, there's actually 3 terms. And when you look at all 3 of these terms, there isn't a common factor. These first two share an x, but the third one does not. And these last two share a factor of 2, common factor of 2, but the first one does not. So this is actually a quadratic that we're going to have to factor. So we need two numbers that are going to add up to 2 and multiply to a negative 8. So hopefully you're thinking about those numbers right now. Those numbers are 4 and negative 2. 4 plus negative 2 adds up to a positive 2. So our factors here are x plus 4 and x minus 2 equals 0. Now we can go ahead and take each factor. Here's our first factor, and here's our second factor, and we can set them equal to 0, and we can solve. Because I already know that opposite numbers add up to 0, I can already figure out my answer without having to set equal to 0. This first one would be a negative 4. Negative 4 plus 4 would be a 0. So negative 4 is our answer for the first factor. And then for the second factor, 2 minus 2 would equal 0, and 0 times 4, because, or 0 times 6, 2 plus 4 would be 6. 0 times 6 would equal 0. So our factors, when we solve for them, x equals negative 4 and it equals 2. Example number 4. So here we have our equation, and we've got one term right here, we've got two terms right here, but this time I'm actually going to eliminate these terms on the right side because I noticed that this x squared is a negative, and that's going to make solving in the end maybe a little bit more challenging. So because it's a negative, I'm going to go ahead and eliminate the terms on this right side. Very easy to do. We just add the opposites. So this is plus x squared here. Make sure we add x squared here. And we've got to subtract this 18. So we've got to also minus an 18. Okay, I'm obviously writing it vertical. If you want to write it out in front, horizontal, you can. So this gets eliminated, this gets eliminated, so our new equation is 0. By the way, what property are we using to add and subtract to both sides? APE and SPE. I know you haven't forgot those. And then we can rewrite this in standard form with our positive x squared out in front, minus 3x minus 18. So you can see again that we do not have a common factor in all three of our terms. So we're going to have to figure out the b and the c. So two numbers that multiply to negative 18, but they add up to a negative 3, negative 6, and a positive 3 multiply to a negative 18, and when we add these numbers together, we get a positive 3. So those are going to be our two factors. So x minus 6, x plus 3 equals 0. And now we've got our two factors. So you're just trying to figure out if you want to set them equal to 0 and solve, you may. And sometimes you might have to, especially if the number in front of these x's was not a 1. But you would set it up like this. X minus 6 equals 0. You'd solve, and then x plus 3 equals 0 and solve. But I'm not going to have to do that because I already know that the number that creates a 0 in this factor is a positive 6. And the number that creates a 0 in the second factor is a negative 3, because those are the opposite numbers. So my answer for x is x equals negative 3 and 6. Last example today. And here we have negative 10 equals negative x squared minus 24. So we're going to do the same exact thing we did in the previous example. Because the x squared term is negative, and I'll make a little note to myself, always want a positive x squared. I'm going to add this x squared, I'm going to add this 24, and then I'm going to make sure I do it to both sides. So plus x squared plus 24. You can rewrite this as x squared, and there should be an x here. I should have written an x here. Made a mistake in the example. This should be negative 10x, sorry. So we have negative or positive x squared minus 10x plus 24, sorry for making that mistake, equals 0. Now we're going to factor this, so two numbers that add to 24, or multiply to 24, but add to a negative 6, x minus 6, and x minus 4. These add to negative 10, and they multiply to a positive 24. And then we know our answers are x equals 4, and x equals 6 in numeric order. Good luck on the problem set.